Hello, welcome to this video. Myself Virendra Kumar and you are watching Hira Cosmos. In this video, we are going to solve the numerical problems related to the physics and that is asked in the previous year. So, बच्चों, you can see the question, a small block starts slipping down from a point B on an inclined plane AB which is making an angle theta with the horizontal section. BC is smooth and the remaining section CA is rough with the coefficient of friction mu. It is found that the block comes to rest as it reaches the bottom point A of the inclined plane. If you are given BC is equal to 2 times AC, the coefficient of friction is given by M is equal to K tan theta, then the value of K is. So you need to find the values of K. That means if you can find the M is the coefficient of friction, right? So relation for the coefficient of friction, then you are done with the problems, right? So let's solve this problem. So what are given? So let's draw some forces which are being applied on this system. So this is the block B, and so let the mass of the block is M, so mg weight is acting downward, right? And this is theta, this becomes if you draw the perpendicular to this inclined plane and another along this inclined plane, so this becomes theta also, and this becomes 90 minus theta. So if you dissolve this downward force mg into vertical and as well as the horizontal component, then this becomes mg cos theta and this becomes mg sin theta, right? So notice here BC portion is smooth, that is for BC coefficient of friction mu is equal to 0, and for AC portion that is rough mu is equal to given that is mu, right? So we have to find the relation. So you know that this block B is slipping down along the inclined plane, and up to C point it is not, there is no friction, there is no frictional forces, so it is sliding down because of this mg sin theta force. So बच्चों point to be noted here is that block starts slipping from point B, that means at point B it is at rest, point B it is at rest, at point B V is equal to 0, and at point when it reaches point A again V is equal to 0, because it is mentioned that block comes to rest as it reaches the bottom point A. So here the kinetic energy of the block at point B is equal to 0 as well as the kinetic energy of the block at point A is equal to 0. So if we apply the work energy theorem, we can solve this problem easily. So by work energy, total work done, work energy theorem states that, see, work energy theorem. Work energy theorem. Total work done is equal to total change in kinetic energy. Total change in kinetic energy, right? So total work done we will calculate from B to C. There is a force acting is the mg sin theta and the displacement is BC, right? And again from C to A, the force acting is, now suppose the block comes here. So when as the block comes here at point C, the frictional force comes into the picture and it will try to oppose the motion. So the frictional force will be along this Fr, right? And that frictional force, so equation would be like this. So equation would be mg sin theta minus Fr into displacement, that is Ca. Total work done, because afterwards the block reaches point A, then this is equal to 0 because the total kinetic energy is 0. There is no change in kinetic energy, 0, starting 0, final 0. So now again Fr is equal to frictional force is equal to mu into n. N means the reaction, normal reaction n, and that will be equal to that component mg cos theta, right? So we can get mu Fr is equal to mu into n is equal to mg cos theta. Using this Fr in this equation, we get mg sin theta into Bc plus mg sin theta minus mu mg cos theta into Ca is equal to 0. So we will solve again on the next page. Mg, so mg sin theta into Bc, mg sin theta into Bc plus in bracket mg sin theta minus mu mg cos theta, mg sin theta minus mu mg cos theta into Ca equals to 0. ये हमारा हो गया इक्वेशन. Now mg is common out from, so sin theta Bc plus sin theta minus mu cos theta into Ca is equal to 0. Now it is given that Bc is equal to 2Ca. Bc is equal to 2 times Ca. So put that value, sin theta into 2Ca plus sin theta minus mu cos theta into Ca equals to 0. So Ca will be common out and will be eliminated. So sin theta, 2 sin theta plus sin theta minus mu cos theta is equal to 0. Therefore 3 sin theta is equal to mu cos theta. You can see that we get mu is equal to 3 sin theta upon cos theta, that is 3 tan theta. So finally we have mu is equal to 3 tan theta. That means coefficient of friction mu can be given by this relation, and it is given that mu or m is equal to k tan theta. So if you get, then you get that k is equal to 3. So in this option k will be equal to 3. K will be equal to 3. So that is the answer, right? So bachcho, I hope that you understand this solution, and this is very important problem related to the Newton's laws of motion and friction, and it is used to come in the every exams, whether it is board exams or your academic school exams or other competitive exams. So learn this, and if you like this video, share with your friends, and if you are watching this Hira Cosmos channel, subscribe the channel immediately, and talk about the Hira Cosmos, because we are providing regularly the physics related concepts, problem solving techniques that will be helpful to all the students who is in the academic 11th class, 12th class, or preparing for the medical JEE examinations, as well as the student who is preparing for the competitive examination like PGT, assistant professorships, and in the other competitive examination that is regularly organized on the national basis. So thank you for watching Hira Cosmos. Thank you so much.